Thank you very much. Just a pleasure to be here. I'm going to cover a bit about the nitrogen fertilizer efficiency of grasses. And let's go a little bit back in time. And I don't know if you remember what happened in 1999, that it was quite consequential on the fertilizers that are used for grasses, because the primary fertilizer, the best fertilizer for grasses, for broadcasting on grasses, was ammonium nitrate. And then, of course, was the Oklahoma bombing that, changed things. Now, very quickly, moisture will alter the nitrogen response. We all know, and you can see these are trials that were carried out in Crossfield back in my Wesco days. We did an amazing amount of trials with grasses. But also, when it comes to ammonium nitrate, you can see that the nitrogen will boost the forage yields, and that's two different sites where you can see 18 years on one side and 19 years on the other side, Now, of course, what's happening is we're broadcasting urea, and when we, I'll come back to that and talk in detail, but part of the problem with urea, it's vulnerable because of the gaseous losses. And the conditions that favor the urea volatilization or gassing off will be, as you can see, prolonged exposure, heavy thatch, maximum contact with residue, moist surface, not wet, but moist, sandy soils, high pH soils with high lime, low organic matter, and of course, warm and drying conditions. And it's amazing. I'll show you a graph from, Oregon State where, they looked at gaseous losses depending on the moisture in the soil. So when it comes to the good old days, the 3400 was the best product. And still, whether you like it or not, we're not using it, but it gave the maximum yields. And you can see, whether we applied, in early fall, early spring, late spring, ammonium nitrate always gave the best results. So the fertilizer technologies now are changing. And of course, we don't have ammonium nitrate anymore. So there are new technologies such as polymer coatings, urease inhibitors, nitrification inhibitors, and of course, alternatives to broadcasting would be ammonium nitrate, will be urea plus management, and with that I mean maybe banding, but banding on grasses, it's just not an easy exercise, or using a urease inhibitor such as Agrotain. So when back, in the 99, 2000, all of a sudden, and then if you remember, Agrium made an announcement they will no longer produce ammonium nitrate. And as a matter of fact, at that time, the government came and said, if you want to the fertilizer dealers, if you want to sell ammonium nitrate, you have to have an insurance of $100 million. So everybody walked away, So we set up, and when I say we, with Wesco at that time, we set up trials here in Peace River to find alternatives to ammonium nitrate. So we used different rates, as you can see, 0, 60, 80, and 100 kilograms per hectare, and late fall or early spring. And we had two locations, one in Rycroft and Peoria, and the other one in Peoria. And the forms that we used were ammonium nitrate, polymer-coated urea, or ESN, urea, and urea treated with MBPT, which is a volatilization inhibitor, always known as Agrotain. So the the grass in Peoria was brome grass, and in Rycroft it was a 50-50 mixture of smooth brome grass and alfalfa. And here is a picture at that time. Richard Lucia, you may recognize the name. He used to be one of the agronomists with Wesco, took that picture, and you can see how, I don't know if, anyway, you can, comparing ESN, ammonium nitrate applied in the fall or in the spring, and urea. And you can right away see what the problem was there with the polymer-coated urea. Same thing in Peoria, you can see there were, with polymer-coated urea, urea, ammonium nitrate, and you can see how the polymer-coated urea, or ESN, greener. It's not advancing as quickly as, So when we finally took the yields, and you can see, and I converted the 60, 80, and 100 kilograms per hectare to pounds per acre. So that makes it 54, 71, and 89. You can see what we found out, that the alternative to using ammonium nitrate was urea treated with Agrotain. So the first column, the white one is ammonium nitrate, then it's urea, then it's polymer-coated urea, or ESN, and then urea treated with Agrotain. And that was the 5 site years average, and you can see how the urea treated with Agrotain proved to be an alternative to ammonium nitrate. And that's again, this is published in the Canadian Journal of Soil Science. So the previous slide was with fall application, and this is with spring application, and you can see how the alternative to ammonium nitrate proved to be urea treated with Agrotain. And stay away from polymer-coated urea 100%. Now, if you make blends, it may be a little bit different. And Len Krzyzanowski, that used to be with Alberta Agriculture, did some work, showing that you can have some results. But using 100% polymer-coated urea, it's not a good idea. And here is a reason for it. Like 7 weeks after the application, we would go and still find polymer-coated urea on the ground. It's not, it has to be hydrolyzed, and the nitrogen has to go through the plastic and into the soil, and that doesn't happen in our conditions. Where it can be used very effectively is places like Iowa and places like that, So the conclusions from that study, as far as the yield, there was overall no difference in forage yields due to the time of application, whether it was fall or spring. The loss in the yield due to volatilization of urea was not quite, in this environment, you don't have as dramatic losses as you would have maybe in places like Lethbridge or, southern Alberta. And urea treated or untreated with MBPT performed comparably with ammonium nitrate at both locations. And polymer-coated urea or controlled release urea did not perform well, and it's not recommended to be broadcasted. So other alternatives to broadcasting of ammonium nitrate is UAN, liquid urea, ammonium sulfate, and blend of urea and ammonium sulfate. And here again, these are studies that were carried out. It's average of many, many trials that we carried out back in the Wesco days, broadcasting urea 3400 ammonium nitrate. If that was 100%, Dribbling 2800 UAN was between 85 and 95%. Broadcasting urea was between 75 and 85%. And spraying UAN was 75 to 80%. But what we found out was that broadcasting ammonium sulfate performed just as well as ammonium nitrate, and in addition, it provided sulfur. So, but depends on the price. That's availability and price. But we found out that ammonium sulfate performs just as well as ammonium nitrate. And I had a number of trials also in Manitoba where we found exactly the same thing, that ammonium sulfate was just as good as ammonium nitrate. Now, Calvin mentioned that a lot of you like to broadcast on snow. So the favorable conditions to broadcast on snow will be a 2 to 4 inch layer of newly fallen, fluffy snow on a previously snow-free field. A period of mild weather that follows the snowfall. Well, we have it this year, but normally it doesn't happen, right? And then, of course, urea pellets should be dissolved more completely through the snow cover in a droplet of melted snow. These conditions normally happen down in the Chinook area. We have an exception this year. We had snow, and all of a sudden it's gone. But keep that in mind that that's, broadcasting. Conditions to avoid is fields that are very wet, the surface is saturated, fields in which the soil is froze in a wet condition, fields that are compacted, drifted, or crusted, have crusted snow, fields with more than 4 inches of fresh snow, and extremely cold weather, that will prevent the urea from melting and penetrating into the soil. The whole idea is to drive the urea into the soil, dissolve it, and move it into the soil. If you have those conditions, it will work. Otherwise, it doesn't. There is a lot of work that was done in Montana State University. You can go even at their website. Dr. Engel did piles and piles of trials where this is some pictures from January 27th, 2010. He broadcasted urea on snow, and then this is again, he broadcast March 2nd, 2011, and he broadcasted urea, but also urea treated with Agrotain. And here are the results from a number of years. I know there's too much information there, but you can see when he was broadcasting in April, the difference was there was 8% loss with urea, half of it with urea and treated with Agrotain. But look, for example, in November and March, where the losses with urea were 31 and 35%, and with Agrotain, treated urea were down to 3 and 18%. So yes, you do reduce the volatilization losses using MBPT or Agrotain, okay? So overall, you can see over the period of 2-3 years, the losses with urea were 20.5%, whereas with urea treated with Agrotain, the losses amounted to 6.3%. Also, there is some, it's amazing because I gave presentations, and this is some work that was done in the 80s and was published early 1990, and I've tried to find work that was done since then. Believe it or not, you won't find anywhere. All like, with Dr. Rennie, they did, he did his PhD, and he applied urea in the fall. And he found out that 35% of the urea that was broadcasted in the fall was lost due to denitrification with the snow melt. So keep that in mind. And 7 to 20% was immobilized in the soil. That is not lost, it's part of the soil. It can be mineralized. So, and they found out that leaching was not responsible for the lower efficiency. And of course, in their study, they used zero-till and conventional till. But that's beside the point. The moral of the story is that urea that they applied in the fall, it was up to 35% of what they applied in the fall was lost due to snow melt in the spring. So keep that in mind. Now, this day and age, we have enhanced efficiency products. So can enhanced efficiency products act or be used as a substitute for ammonium nitrate? And I want to go through the definition of enhanced efficiency product. Please pay attention to that, because right now, after April 1st, 2013, and that's not an April Fool's joke, when they eliminated the requirement for fertilizers to prove the efficacy, there are a whole bunch of products out there, and you got to be very, very careful. An enhanced efficiency product is a term describing products that with characteristics that allow increased plant uptake. The reason for that is they minimize losses, whether those are volatilization losses, leaching, but an enhanced efficiency product has to increase the efficiency of the fertilizer, in this particular case of nitrogen. What does that mean? If you increase, if you get the maximum yield with your forages with 100 pounds of urea, as an example, if you use enhanced efficiency product that improves everything, should you be using 100 pounds? No, you shouldn't. You should be using maybe 70 or 80. You'll get the same results. So keep that in mind. That's very important. So there are different types of enhanced efficiency products. There are uncoated, slowly fertilizers now. These are aldehyde. You don't find them anymore here. IBDU, triazines. You're going to find them down in California. And even in the 60s, when I was doing my bachelor's degree in Greece, some of these products were still available at that time. There are products with physical coating, and that is polymer-coated urea, such as the ESN, and stabilized material, which contain nitrification or volatilization inhibitors. Where do they fit? If you go through the 4R nutrient stewardship principle, right rate, right place, right time, and right source, these products would fit there. But make sure that you are using products that are backed up by scientific research. That's really, really important. So when it comes to ammonia volatilization, this is when you apply urea to the soil, it will act with water. It's called hydrolysis. Hydro in Greek means water. So what happens, it's hydrolyzed, and it's mediated by urease. And it will produce ammonium. So urea is converted to ammonium. Great, ammonium is positive. It will be absorbed onto the surface of the clay and so on. The problem is that you have that next molecule. That's the carbonate. And what that does, it increases the pH of the soil. And you can see down there, how that soil, a pH of 6.5, but next to the urea molecule, it went up to 9.5. And again, if you go into Montana State University, they did all kinds of different research with that. This is something, this graph, what tells you is that if the soil pH is less than about 7.2, 7.3, the ammonium form dominates. But as the pH goes up to 8, 9, what happens, the ammonium is converted to ammonia. And ammonia is gas. And off it goes in the air. That's why banding, deep banding, but like I said, with grasses, it's kind of difficult to do that. Why deep banding works with urea, because you put it down 2.5 inches, it goes through exactly the same reactions, but the gas that is being generated is absorbed by the soil. But when you broadcast it, there is nothing to hold it, and off it goes up in the air. So keep that in mind. So when to consider a urease inhibitor? When the potential for volatilization is high, when you surface broadcast urea or UAN, prolonged exposure with no rain, the moisture, in the morning, that can really lead to big losses. Heavy residue and heavy dews followed by warm, windy conditions. Now, some people will tell you, peace of mind and insurance, but that costs money. So, that is, yeah, some people do that for peace of mind and insurance, but, if it rains the next day, you wasted your money. So this is the one that I told you from Oregon State University. Look at this. This was a dry soil. When they applied 1/10 of an inch of rain, they got just about 50% of the urea lost due to volatilization. With less than 1/10 of an inch, they got up to 75 and 80%. With half an inch, only 4 or 5%, and with 8/10 of an inch of water, the volatilization went down to nothing. And actually, it's kind of interesting because, sometimes producers phone me, and I have a good example of a fellow north of Swift Current in Saskatchewan phoned me, and he says, well, I want to go and broadcast them. What should I do? I said, well, what's your forecast? Do you think it's going to rain? Oh, yeah, he says. Well, I said, go do it. Oh, he was so thankful because he got some really good yields. So keep that in mind. That is, if you're going to irrigate, that's a different story. But if you're a dry land and you go and broadcast, and even the morning dew that comes on the surface is worst case scenario, because that corresponds to that 1/10, less than 1/10 of an inch moisture coming up. So keep that in mind. It's very important. So this is another example of brome grass yield benefit with Agrotain, urea treated with Agrotain. You can see these are 4 years and the average, and on average they got 313 bushels more per acre. But that's, again, this is with, it's not with grasses. When it comes to perennial ryegrass fertility trial that was carried out actually in Minnesota, you can see they use urea, they use Super U, which is urea that contains both volatilization and nitrification inhibitor. They use a blend of 50% urea and 50% ESN, and urea with Agrotain, and of course they got the maximum yield with Super U. That makes sense because Super U has both volatilization and nitrification inhibitors included. So that is, very important. And here is again the average of the trials that we carried out here in the Peace River country, and you can see how we got maximum yield in the fall applied urea and ammonium nitrate, and you can see in the spring with the yellow is ammonium nitrate, then controlled release urea, and then urea treated with Agrotain. So the moral of the story is do not use polymer-coated urea when it comes to broadcasting nitrogen. Nitrification now is a reaction where, and actually this is a little bit easier to see. I meant to take that slide out, my apologies. We apply urea, it goes into the soil, it becomes ammonium, as I mentioned before, and that is through urease, that's the reaction. But then there is another enzyme, the ammonium monoxygenase, that helps the ammonium to be converted to nitrate. And actually in our environment, probably 85, 90%, maybe even more of the nitrogen that is taken up by crops is in a nitrate form, not the ammonia form. It doesn't last ammonia doesn't last very much because that reaction from ammonium to nitrate takes place in the soil. So we have the nitrification. And what happens now, once we have nitrate in the soil, it can either go up in the air as nitrous oxide or denitrification. Now, nitrous oxide is only a small fraction of the denitrification. 95% is molecular nitrogen, But nevertheless, it can go up in the air. Leaching in our environment is not really a big deal, but nevertheless, those are the losses. So, if we are able to inhibit the reaction caused by monoxygenate, you can see we can reduce the nitrate, eliminate denitrification, and minimize leaching as well. So and that's why Super U is something that works very well, because it does contain DCD, which is a chemical that acts on the ammonium monoxygenate. So you can see that, the fertilizer that's used in, you can have urea with Agrotain, MBPT, surface coated. That's some of the work that was carried out at the University of Saskatchewan. They carried out some work with these products. I'm sorry. I put it in the wrong place. This is the work that Calvin did here it's a 7-year average, and this is with ammonium nitrate, urea plus Agrotain, polymer-coated urea, and Super U. And you can see the moral of the story. In his work, he concluded exactly the same things we concluded too. Do not use polymer-coated urea. Do not broadcast. It's the worst-case scenario. Anyway, so with this, here is the work that was carried out at the University of Saskatchewan. And they had Agrotain, Alzon. It's a nitrification inhibitor they brought from Europe, the control, Super U, and urea. And they went out, and you can see they measure over the years, the losses. And of course, you can see the maximum loss was with urea. Alzon did reduce it a little bit. Agrotain more, but look at Super U. It just about brought it to the level of control. So what I did is I got their individual data, and this is, Agrotain, Alzon, control, Super U, and urea. And then I subtracted the control from all these numbers and divided by the 100 pounds. The PhD student, Yannikos, they did this experiment, used 100 pounds of nitrogen, and here is the result. So you can see the average nitrogen loss. With urea was 23%. With Alzon, which was a nitrification inhibitor but not volatilization inhibitor, was down to 13. Agrotain was down to 6%, But look at that, with Super U was down to 2%. So you can see how the nitrification inhibitors work. So another thing, this is, I gave, it's not with grasses, but I thought I should bring that up. I carried out that research using Super U that I mentioned. Now, I wanted to mention that Super U, it contains 8,500 parts per million of DCD. But there are products out there that they say that, oh, you can take DCD and treat urea with DCD. And there is one product that, that I used with, 28% DCD. The reason, now, there was a lot of research that was carried out, actually started in Canada back in the 80s, showing that the best protection that you get using nitrification inhibitor, DCD as an example, is when it is 1% of the urea in the product. You cannot coat urea with 1% DCD. You're going to create soup, It's so what they do when they produce Super U, they inject the DCD when urea is what they call it in liqueur form. In other words, before they, granulate it, and then they make the granules. Now, there are products that say, oh, you can just take urea and treat it with DCD. I'm sorry. You can only use a small portion, and if you go into all the research that has been carried out, it doesn't work very well. And this is, like I used a product, that had 28% DCD, and I used 2 quarts per ton, 4 quarts per ton, and then 2 products that have the DCD, like Super U, as I mentioned. And what we found out of that research, go back, is that we could not get maximum yield with these products. I'm bringing that up only from the point of view to protect you from sales of products. Like I've given many presentations on the good, the bad, and the ugly of new products. So, be very, very cognizant. Demand to see third-party research and third-party, university research and so forth. A lot of things, these days what counts is a good sales plan. But, anyway, I would leave it at that. And I want to conclude the enhanced efficiency products with this graph. I mentioned an enhanced efficiency product increases the efficiency of nitrogen. Now, these are not with grasses. They're with canola. But what I'm showing you here, you can see the white graphs are 70% and 100% of urea, whereas the green and the blue are 70% of Agrotain and Super U. And this is the average of 17 trials. Look at that. Got the same yield with 70% of the enhanced efficiency products as we got with urea when they were broadcasted. So keep that in mind. If an enhanced efficiency product does what they say it does, then you don't have to use it at 100%. You have the recommended rate and you pick up 70 or 80% of the recommended rate. Because normally you look at Agrotain will be 150, 160 bucks more. I don't know, Super U maybe $200 and $220 more than urea. If you're not going to get a benefit, why you should be using this, But you do get a benefit when you broadcast nitrogen, so keep that in mind. Now, Calvin asked me to cover a little bit on potassium, and I have 3-4 slides on potassium. Are there any questions on nitrogen before I move to potassium? Oh, I put you to, oh, there.
Well, like seriously, so like with reducing because of the, if I use Agrotain on my fescue, so now I'm going to run out and instead of doing, say, 200 pounds of actual product, I only have to do 140.
Well, now you're going to have to use maybe 140, 150, yeah. If it does, you know, what it's, sure, yeah. 80% is the best, you know, 160 would be the best solution, yes. You will get the same results.
But you would be confident that 160 pounds of Agrotain-coated urea will do the same job?
Yes. I'm confident because, like I said, I've done piles of research with enhanced efficiency products, yes. Unless if you are in a situation like, I mean, you know, if it's a dry year, I'm sorry, it doesn't matter what you're using, you know. But if it is a normal year or a wet year, you're going to get, yeah, you'll get the same yield. Otherwise, why use an enhanced efficiency product? If you use the best management practices, if 200 pounds is the best management practice, then 160 will do the trick. But if it's not the best management practice, then it's a different story. Oh, if you're applying urea ahead of a rain, you know, and you're 100% it's going to rain, don't put Agrotain. Why waste your money? It's just the moral of the story. Yeah? And I used to work for Coke, and I used to tell farmers, hey, you know something? You got to use the product when you need it. If you don't need it, why use it? It doesn't make any sense. Yes, they bring up, yeah, calcium, yeah, they bring, they're walking away like in PI, you know, for potatoes, you got to use ammonium nitrate. But now they're walking away from it and they bring calcium ammonium nitrate. The moral of the story is it's going to cost a pile of money to bring it here. And that's, you know.
We're producing it because it's going to the diamond mines.
Yeah. Oh, it works very well. Yeah. Absolutely, yes. Calcium ammonium nitrate, yes. You wouldn't use it at soils that are high in calcium carbonate, you know. But here, for example, in this area, you don't have to worry about that, you know. Your soils, normally the pH is not very high. Yep. Well, we may not have time to cover the potassium now. So maybe we should... Oh, okay, very quickly. This is a comparison of nutrient amounts in the plants. And you can see the alfalfa, the pink color is the nitrogen, and then you see potassium is the next one that is being taken up in very high quantities compared to sulfur and phosphorus. So, moral of the story is that forages take up a lot of potassium. So the fertility management will influence the potassium removal. And you can see this again from back in the day. I got a lot of results from my Westco days, you know. The unfertilized, it removed 110 pounds per acre. When we fertilized with nitrogen and phosphorus, we were up, you know, we over doubled the yield, and of course the removal went up as well. So when it comes to the alfalfa, this is a study, you know, that was carried down in with alfalfa in Brandon, Manitoba, and you can see how the potassium rates increase the yield and the potassium content, but also look at the tremendous impact on protein. Now, potassium is not a component of protein, but contributes to the formation of the protein in the plant. Another thing, intensive grass management mines the soil potassium, and you can see that's 19 years average, and this was measured 16 years after the production, how, increasing the yield, how we remove the potassium, and look at how the soil test. It was 600 parts per million, and it dropped down to about 200, and then bumped up again a little bit in the 0 to 6 inch depth. So there is a tremendous impact. And of course, we all know when we grow crops, and for grain, we remove the grain and we leave the straw behind. But when you grow forages, everything is, and you harvest everything, you can see that you remove 100% of the potassium. Whereas with crops, you will only remove about 23, 25% of the potassium. So I just wanted to point that out. And then another thing that I want to make you aware, and actually I was invited a few years back, and I gave a whole presentation on that by Alberta Agriculture. Be aware of potassium recommendations based on base cation saturation ratio. Throw that out. I know the labs do it. Throw that out means absolutely nothing. Even the people who introduced that back in the 50s, they walked away from it. And they say that, the ideal is 65% calcium, 10% magnesium, 5% potassium. That's the ideal soil. They took it out of a hat. That doesn't mean a darn thing. So do not use recommendations that are based on the base cation saturation ratio. Because, the other thing, if you put, I had one more slide, but I took it out. If you put too much potassium on grasses and you have animals feeding on it, you can have tetany. So because of the very high potassium levels in the grass. So, just wanted to mention that very, very briefly. And thank you so much for the opportunity to speak to you. Thank you.